back to Brains Are Beautiful. In today's episode, we're going to be talking about logarithms. So if there's one takeaway you can get from this video, it's the simple phrase, logarithms are exponents. And it's the truth. I can't remember how many times all my teachers said this growing up. Logarithms are exponents. A logarithm is an exponent. And so from there, we have two main kind of categories, I should say, of logarithms. So we have log, and usually this is assumed to be base 10, but we'll talk about that in a second. Log of some number, some variable, and we have the natural log, or the ln, of some number, variable, etc. So the main difference between these is the bases. So when I talk about bases, there's assumed there's this little 10 here, and it can be other numbers, which we'll see in future videos actually, but for all intents and purposes right now it's assumed there's a base 10 there. So a log has a base 10, and I'll explain that further in just a little bit. And then for ln, we can assume there is an e right there, the e that you've probably raised to a power before, so that type of e. Base e. So it's a very specific number. It's not like it's just some arbitrary variable. Okay, so I think the best way to explain these are with examples. I'm an example person, as you know if you've watched other videos. So for now, we're just going to jump right into a couple examples, and then we're going to kind of take it a step back and explain the formula and how to use it. So an example for an log would be log of, let's say, 1,000. And again, I don't have to actually write base 10, but I'm going to for right now, just to remind us since we're learning. And we're going to say that this expression equals question mark. And so the way you go about solving this, if you want to find the question mark, you say that 10 to the power of the question mark, so this raised to this, equals the 1,000. So this might look a little daunting, kind of weird, but we actually all know that 10 cubed, or 10 to the third power, 10 times 10 times 10 equals 1,000. So therefore, we know that the question mark has to equal 3, because we're multiplying by 10 3 times. And we can do the same type of thing, sort of, with the ln, only difference is, well, you'll see in a second. The ln of 2 equals question mark, and I'm just going to put in the base e for us. So we can technically say e to the question mark equals 2. Unfortunately, though, there is no whole easy number that can bring about an epiphany of what e raised to equals 2. And so probably the best way to do this is to type in ln of 2 on your calculator. And I brought this example up so I could talk about your calculator a little bit. If you have one of the TI 82, 83, 84, somewhere in there, you have all these cool functions on it. And over on the left side, probably about 2 buttons from the bottom, you have something that says log and you have something that says ln. And so what says ln, that's for this guy right here. That's for the natural log. The log would be for this one right here, because that's for the log itself. And so we can type in the ln of 2 into our calculators, and we get approximately 0.69. So let's say we have, and this is kind of demonstrating a concept or a basic principle more than anything, but let's say we have the log of 10, and of course, just for us, log base 10 of 10. So we know 10 to the question mark equals 10. And remember, this 10 raised to this question mark equals what's inside parentheses. A lot of 10s going on. I know, guys. Hang in there. But basically, we know that 10 raised to what equals 10? Well, when you raise something to 1, it always equals itself. So we know that the question mark has to equal 1 because 10 is 10. And so that's kind of one of the basic ideas of that one. So we can rewrite this. Log of 10 equals 1. So that's your answer. And then over here we have, let's say we have ln of e to the 4.5. And we want to know what this equals. And of course we can put e here for our reference. And so we would know that e raised to what power equals e to the 4.5. Well, anything, if e is raised to the 4.5, if it has to equal e raised to something, we know that the question mark's got to be 4.5. Another way your teachers might do this is actually, the correct way to do this is actually through the power rule. That's actually going into some of the properties of the logarithms and the exponents, which we'll talk about in the second logarithms video. So stay tuned because there's more to come. But you could, for now, just say that since you're raising a power up here to the same base of the ln, then that just has to equal 4.5. Making a bit of an assumption right there, but you'll see in the power rule how the correct, thorough way to do it's done. So before I go really quick, we're wrapping it up, but we do want to go over some of the basic formulas. If you're starting to see a pattern about the base raised to the question mark and it has to equal what's inside the logarithm, you are 100% correct. So I'm just going to give you the basic formulas that will always work no matter what. You have the log of a, x, and b. So a is your base, x is your variable or your number that you're trying to solve the log of, and b would, in other examples, be your question marks. And we knew that a to the b equaled x. And this rule will always work for your logs. And for your ln's, it's a similar rule. We have ln, of course, to the e of x right there equals, we're going to say b again, and it's the same rule, e to the b equals x. So these rules will never let you down. They are your new best friends. And that concludes our introduction to logarithms. If you like this video, please give it a thumbs up, like it, and feel free to comment below, leave any questions, comments, or concerns. And I hope to see you around my channel some more. Please hit the subscribe button if you're into learning more math, and stay tuned for more videos. All right, thanks for watching, everyone. And remember, brains are beautiful.